All right, folks, it's Bass Action back in action here. In this video, we are going to talk about instantaneous rate of change and the difference quotient. This is really a preview to how your calculus class is going to start next year. Now, what we want to remember is that we've already talked about the average rate of change, which gave us the slope of the secant line. So if we chose any 2 points on our curve and we found its average rate of change, its slope, what that tells us is that we can see that all these little individual secant lines are changing. The rate of change of this graph is changing as we move along it. So this red line was our average rate of change. What we're going to do in this video is, instead of having these 2 points on our curve very far apart, x and this x plus h, we are going to make this h so small, so infinitesimally small, that it's basically 0. And what that's ultimately going to give us is the slope of a tangent line. Now, before we can do that, what we need to do is we need to find a new, essentially, equation, and it's going to be called our difference quotient. And what we can see is that this is our formula that we're going to follow. Now, we've got to be comfortable with our function composition to do that. So I've got an example over here that we're going to jump into. Our function is negative 2x squared plus x. Now, what we're going to do, we're following this formula right here, and we have to remember to do all of it. So I'm going to write out all of the steps. Some of them you might be able to eventually combine. Remember, when we're doing our function composition, we are going to replace this first part, x plus h, is going to go in both places for x. So I'm going to have a negative 2 and then an x plus h squared plus another x plus h. That takes care of the f of x plus h portion. Now we need to subtract the entire f of x function. So I'm going to initially put that in parentheses so that we can really keep track of what we're doing. And this whole thing is over h. Now, the ultimate goal on a difference quotient problem is to eventually cancel this h. It is not to eliminate all the h's in the problem. It's to eventually cancel specifically the h that's in the denominator of the formula when we begin. Now, we're going to continue expanding. Some students I know like to rewrite this x plus h, and we need to expand that. I like to save myself a little bit of work, and let's write this x plus h and x plus h here to remind ourselves of that. So we can go ahead and we can continue on. Some of this you can skip this step eventually. So we'll say x squared plus 2xh plus h squared plus x plus h. Now I'm going to distribute my negative, plus 2x squared minus x. Now again, this is all over h. Don't get lazy and stop writing that over h. Now we're going to distribute our negative 2. So I'll have a negative 2x squared minus 4xh minus 2h squared plus x plus h plus 2x squared minus x. And then this is all over h. At this point, we should start to see some things canceled, or start to cancel. So I've got a negative 2x squared and a positive 2x squared. I have a positive x and I have a negative x. Everything that's left over has an h in it. So all of this has an h, and then I still have this h here. Everything that you have left at this point on a quadratic should have an h in it. What I'm going to do is I'm going to factor the h out of that. So if I factor out the h, I'm left with a negative 4x minus a 2h plus a 1, and that's all over h. And as I mentioned way up here in the beginning, I said our ultimate goal is to be able to cancel the h that's in the denominator. And since everything here had an h, I could factor the h, and then that h will cancel. So our final answer for the difference quotient question is the negative 4x minus 2h plus 1. This is our final answer. If you're asked to find the difference quotient, this is your answer. Now what we're going to do is we're going to move into that idea where I said we're going to move these so close together, it's going to create a tangent line. And that's what we're going to do down here. So in this step B, it says find the slope of the tangent line that's going to pass through this point 2f of 2 by letting our h equal this really, really tiny decimal at this x equals 2. Now, this 2 is this 2, okay? It's supposed to be the same 2. When we look at this point 0, 0, 0, 1, what we're actually going to just think to ourselves is that this is effectively 0. Now, to find the slope of our tangent line, first of all, let's figure out what is the point 2f of 2 on our graph. Now, our function, our original function, was f of x equals negative 2x squared plus x. If we substitute 2 into this function, we're going to have negative 2 times a 4 plus a 2. So I've got a negative 8 plus 2 is going to give me a negative 6. So my point on my graph is the point 2, negative 6. Now, over here, this is the graph of this function. So we can even go find this point on our graph. So let's do that. Let's make sure that it's on our graph. So we've got the point 2, negative 6. Sure enough, it's right there. Now, the slope of the tangent line is going to be, we're going to take this 2 and we're going to substitute it into our difference quotient, and everywhere that we see the h, which is only one spot, we're going to treat that like a 0. So our slope, let's label that slope, will be a negative 4 times the 2 minus a 2 times 0, because we're treating h as 0, plus 1. That's going to give us a negative 8 plus a 1. So our slope here is a negative 7. That means that from this point right here, we can graph a slope of negative 7. So we can go all the way up 7 and back 1. Now you got to be a little bit careful because notice how I scaled this for us, but that would give us another point on our line right there. And then we can draw in that line. And if we draw it in, you probably have a nice straight edge. You can make yours a little better than I can because I'm just freehanding it. But if we draw that line in, it should appear to be tangent to our graph. Now again, mine doesn't look very good because I had to freehand that. We can also write the equation for this line that we just drew. And now we're going to write this in point slope form. Now remember, we have our point and we have our slope. So all we need to do is say y plus 6, our slope is negative 7, and x minus 2. That is the equation for our line. Now, if you were asked to get that into slope-intercept form, we could certainly do that, but most of the time, we'll have you stop here at point-slope form. Sometimes the answer key will be written in slope-intercept form, so you need to rearrange it, but if I ask you to just write it or tell you point-slope form, I would just leave it here. All right, that's all that we've got, and then we're going to do some more examples with this and look at the difference quotient in a variety of types of functions.